This is UNC, I'm Andrew, and top stories for today. A homeowner finds its couch trying to give birth to a cat. In another news, there have been sighting of mattresses trying to flee from this town.
Emergency news. Man to Mars rocket mission was exploded due to internal failure. As further study for scientific development, new group of engineers were recruited by the Palo Alto Factory, California, United States to study, observe, and analyze the quality control of the memory chips produced by the factory. Without further ado, I will pass to Andrew, the reporter, to interview the chosen engineers about the quality control of the product and the observed production of the memory chips.
So, Audra, what exactly is quality control and reliability?
Well, quality control is actually an operational technique that is used to fulfill the quality requirement of a product, where the product that is being developed is identified for any bugs or mistakes that might be present in it. It differs with reliability, as reliability is more to the probability of a product working or performing its tasks for a specified time, and also whether it can operate in a defined environment without breaking down or failing in said environment. Although both quality control and reliability are broadly used in factories and also manufacturing industries.
Oh, I see. So, let me get this straight. Both of these are different, right? So, can you tell me more about the differences between quality control and reliability?
Yes, of course. So quality control is more to the quality of the product itself and how well it performs its designated tasks or functions. For a simple example, a washing machine that is safe and easy to use will also energy saving can be considered as high quality, whereas reliability is to see how well the product can last and maintain its original quality over time through numerous conditions. Taking the same example, the washing machine still operates well and safe even after using it for years.
Now I understand more about the differences between those two. So, how does quality control actually works in the industry?
Okay, to be more in depth, quality control has four different parts. The first being external quality control, where the products or data are sent outside to business affiliated with organization. Then we have the internal quality control, where we rely on protocol established in-house to check the system. Next, there is statistical quality control, in which statistics are used widely and usually done in post-production to assess quality parameters of the product. Lastly, we have process control. Here, we can see if activities at each process are operating within the acceptable range and making sure that the machine operates correctly and that the product has no defects. So the quality control process can be separated in three, which are IQC, which is incoming quality control, OQC, outgoing quality control, and IPQC, in-process quality control.
That's very interesting. So, who and where does quality applies to?
Quality actually applies to everything from the product itself, the task given, services, and even decision. We question how well is it? Is it good enough? Can it be improved? How do we improve it? Everyone is responsible to have quality, from the CEO down to the intern. So to explain further on what tools we use, I will pass to one of our esteemed engineer, Ms. Norshamim Yusuf.
Okay, Ms. Shamimi, before we go in details about the tools used in your research, can you generally explain about the origin of the tools?
Okay, thank you for the question. So the 7 quality tools were originally developed by Japanese professor of engineering, which is Kaoru Ishikawa. They were implemented by Japan's industrial training program during the country's post-war period as it turned to statistical quality control as a means of quality assurance. Their goal was to implement basic, user-friendly tools that workers from various backgrounds with varied skill sets could implement without extensive training. They are frequently implemented in conjunction with today's most widely used process improvement methodologies, including various facets of Six Sigma, continuous improvement processes, and also lean management.
Next, I would like to know what are the tools that will be applied for your team research.
Okay, for the first step to solve this problem is we will use check sheet. It is a simple form with certain formats that can aid us to record the data in a firm systematically. The main advantage of check sheets are to be very easily to apply and understand, and it can make a clear picture of the situation and condition of the organization. They are efficient and powerful tools to identify frequently problem. In this case, we will use tally check sheets. So for the second tool is histogram, which is it is used to describe a sense of frequency distribution of observed value of variables. It is a type of bar chart that visualizes both attribute and also variable of the data of product. Besides, assists us to show the distributions of the data and the amount of variations within a process. It should be designed properly for those who are working into the operations process so that they can easily utilize and understand them. Also, a histogram can be applied to investigate and identify the underlying distributions of the variable being explored. So the last tool to use in this research is control chart. It is a special form of front chart that it illustrates the amount and nature of variations in the process over time. It also describes and draw what has been happening in the process. So thus, it is very important to apply control chart because it can observe and monitor process to study process that is in statistical control. According to the samplings or sampling between UCL and LCL, which is upper control limit and also lower control limit, there will be no problem with quality. While if the statistical control is not between the UCL and also LCL, the process is out of control. Hence, the main aims of the control chart is to prevent the defects in the process.
We will now have an audio interview with the third engineer as we cannot reach out to her face to face due to unavailability. So, Amy, what do you observe from the result of the production? So we have analyzed the weight of memory chips that is produced by the factory in Palo Alto, California, United States, by using histogram and control charts. The chosen technique consisted of analyzing the weight memory chip using a standard of 3.56 gram for each shift day from Monday to Friday and grouping the weight memory chip data. Morning shifts are representative in statistic for each shift. The goal is to make data analysis more straightforward so it's easier to analyze. The frequency of the data was studied and assessed within different 11 class ranges or intervals using the data given in the preceding chapter. This tool has the advantage of being simple to use and comprehend, resulting in a clear picture of the issue and organizational state. They are good and strong tools for discovering frequent concerns, but they lack the ability to investigate workplace quality issues. As a result of the tabulated check sheets, the obvious frequency problem for the class range of 3.980 until 4.0449 with a frequency range of 211 to 240 was discovered. The frequency of the data was studied and assessed within different 11 class ranges or intervals using the data given in the preceding chapter. This tool has the advantage of being simple to use and comprehend, resulting in a clear picture of the issue and organizational state. They are good and strong tools for discovering frequent concerns, but they lack the ability to investigate workplace quality issues. As a result of the tabulated check sheets, the obvious frequency problem for the class range of 3.980 until 4.0449 with a frequency range of 211 to 240 was discovered. The histogram has result which the frequency polygon reveals the vast range of weight data from 3 gram to 4 gram, but the histogram shows a random distribution that the frequency displayed for each class range was nearly identical for each limit. The cell with a border of 3.98 Antic 4.049 on the other hand has a frequency range of 196 to 240. For Monday through to Thursday shift, the form of the plotted histogram was practically skewed to the right, and most of the data on the left appears to be close to the normal weight of 3.56 gram. Furthermore, in order to fulfill standards, factory staff endeavor to preserve memory quality. The histogram shows a more consistent data distribution with less volatility. 20 subgroups were selected for sampling with a sample size of 5 in order to achieve better randomization results. For each day shift, a control chart was created. Then the 5-day shift is statistically controlled to summarize the data, which is stable, because no point exceed the control limits, and the control chart shows a normal distribution with no outliers. However, stable process did not indicate that it was a zero defect process. Lastly, we get on hold with the fourth engineer Amira to see what her hopes and prediction for the upcoming days.
Next, Miss, can we know issues that your team faced while doing this research, and can you explain a little bit about it and how you guys face it?
Okay, thank you. That's such a good questions. Okay, issues that we encountered while doing this project with one of the quality tools that we will use, which is a check sheet. This tool has its advantage of being simple to use and comprehend, which can have a clear pictures of the issue and organizational state. And they're also good and can define a strong tool for discovering frequent concerns. But then, not all good things can be perfect. So this tool is lacking the ability to investigate workplace quality issues. So to overcome these issues, to improve the issues, we can use like Pareto chart and histogram, so that we can have the best result other than check sheet.
So, Ms. Nur Amira, I want to ask, can we know what is your prediction about quality control in the future? I mean, how it's going to help the manufacturing industry?
Okay, for this question, we take example from Prama Manufacturing Labs. Industry 4.0 has a potential to change each element of pharmaceutical production laboratories over the next 5 to 10 years, using new technologies from connection to sophisticated analytics, robot and automations. In the first real-life examples, productivity has increased in mature and efficient laboratories by 30 to 40%. A comprehensive spectrum of improvement might lead to a decrease in overall quality control expenses of more than 50%. Digitalization and automation will also provide improved quality and compliance by eliminating manual mistakes and variability, and by providing quicker and more efficient issue solving. Use cases indicated a decrease in deviations of more than 65% and closing time of more than 90%. Cost reduction can in itself be worth millions to avoid severe compliance problems. In addition, better agility and a shorter duration of testing might cut the QC laboratory lead times by 60 to 70% and ultimately lead to the real-time release.
Thank you, Miss.
Well, that is all we obtained from this breaking news. We will see again later for upcoming news. From Sri Pentas, have a good day ahead.